All right, so let's look at a series circuit. I have one path here, two resistors on it. I could have put the resistor over here or over here. It didn't matter. As long as they're on the same path, that's a series circuit. These two things are in series. Let's give this, let's say, 6 ohms and, I don't know, 4 ohms. I'm going to make this, let's say, a 20-volt source. Okay, so I'm going to fill in some numbers here in my table. I know the source is 20 volts. I know the resistors are 6 ohms and 4 ohms. And now let's start crunching some numbers. So if we want to tackle this, that 20 volts really doesn't go for each resistor. That's a 20 volts across the whole thing, right? So the voltage here is going to get split up between those two. We don't exactly know how yet. Spoiler warning, it's proportional. If they were equal, they'd split in half, but they're not equal. So we'll crunch some numbers with it. So let's find the current first. Now, if we were looking at the current pushing out of this battery from the perspective of that source, that battery, that whatever that is, trying to push those electrons through, it's going to feel a certain amount of resistance. Now, it's got to push electrons through both of these, both resistor A and resistor B. So the resistance in total that it feels is going to be those two resistances added up. Now, you can do this in series. In parallel, it gets a little trickier. But that's 6 ohms plus 4 ohms, and that gives us 10 ohms for a total resistance. Okay, so if we have a total voltage, V total, or the V source, sometimes we call it, let's find the current. Current equals voltage divided by resistance. Green means go, red means stop. I like the way I color coordinated that. Totally planned that. I totally thought ahead and realized I would do that. 20 volts, total resistance of 10 ohms should give us a current of 20 divided by 10, 2 amps. Now, 2 coulombs of charge per second coming out of that battery, 2 amps. Now, is that the same for each of the resistors? Well, yeah, there's only one path. If 2 amps are coming out of here, 2 amps are flowing through here, and 2 amps are flowing through here. And guess what? Where else are they going to go? 2 amps are flowing through there. Okay, so I got 2 amps, 2 amps, 2 amps. And this is the same in series. All those things are the same. But what about the voltage, Mr. J? Well, all right, cool. Ohm's law again. Voltage equals current times resistance. And now we just look at this in terms of one of those. So voltage equals current of 2 amps. If you push that through a resistance of 4 ohms, then you're going to get a voltage of, and I should say VB, because the voltage on B is what I'm looking at, a voltage of 8 volts. So there's 8 volts across that resistor B, across the 4 ohm resistor. Resistor B, okay, 8 volts. Now I could run Ohm's law again for resistor A, but I know I have a total of 20 ohm or 20 volts here, of voltage. And really, if I'm using up 8 here, what's left? Well, 20 minus 8. So I got 12 volts left if you go over there. And if you did it, 6 ohms times 2 amps, you'll get 12 volts. So it's not a shocker, right? So in series, the current is the same. Also in series, the voltage adds up. Right, so voltage splits and adds up. It gets split up across everything. And if you wanted to get a total resistance, well, you just added them up. You could also do voltage divided by current to get resistance. 20 divided by 2, you get a total of 10 ohms of resistance. And that is analyzing a series circuit. Let's get everything in frame. Boom. There you go. Current is the same. Voltage adds up to the total.